Welcome back, future architects. I am absolutely thrilled to welcome you to Session 8 of Phase 1, right here at CloudBridge Tech Labs. You've made it this far, and today we're really stepping up our game. We're diving into gateways of scale. We're going to answer a really fundamental question. How exactly do we handle web traffic when it just absolutely explodes? How do we keep our systems online, and more importantly, secure? Well, let's get right into it. Here is our roadmap for today's explainer. We'll start with a quick welcome to Session 8, move into scaling with load balancers, securing with reverse proxies, hit an interactive understanding check, and finally go over your mandatory practice tasks. Let's roll. Welcome to Session 8 of CloudBridge Tech Labs Phase 1. Okay, let's dive into this and look at the foundational problem we're actually solving today.
Ultimately, our core architecture goal boils down to two main things: distributing traffic and securing backend servers. Think about it. When you're building applications that people actually want to use, managing that crazy server load and maintaining ironclad security, those are easily the two biggest hurdles you're going to face when scaling up. Because if you get this wrong, your app crashes the exact second it goes viral. And frankly, we don't build systems to crash, right? We build them to thrive under pressure.
Section 2, scaling with load balancers. Let's talk about distributing that load. I always like to think of load balancers as the highly efficient traffic cops of your network. Without one, all your users hit a single server. And what happens when 10,000 users hit it at the exact same millisecond? Boom. Overload and downtime. It's a terrifying single point of failure. But with a load balancer, it stands right there at the intersection of the internet and your servers. The traffic hits the balancer first, and then it's safely, beautifully distributed to App 1 and App 2. No single server takes the full brunt of the internet.
And the benefits of distributing this traffic? They are absolutely essential for any modern application. First up, high availability. That just means your app stays online even if a specific server requires maintenance. Second is scalability. You can seamlessly add App 3, App 4, and App 5 right behind the load balancer as your user base grows. And third, fault tolerance. If one server completely dies, the load balancer instantly detects it and routes traffic only to the healthy servers. Pretty brilliant, right? And this brilliantly illustrates how the concept applies out there in the real world. Think about an AWS example. The Amazon Web Services Application Load Balancer, or ALB. It automatically distributes incoming application traffic across multiple compute targets, like EC2 instances. It's doing exactly what we just talked about, but at an incredibly robust enterprise scale. All right, Section 3, securing with reverse proxies. It's time to meet the ultimate bouncer. So if the load balancer is the traffic cop, the reverse proxy is the heavy-duty bouncer sitting right at your front door. Here's how it plays out. Step 1. The user requests access to your site. Step 2, a reverse proxy, like Nginx, intercepts that request. Step 3, only after the bouncer approves it does the actual application safely process the request. Notice how the user's request never directly touches the backend application server? That separation is literally the key to a secure architecture. Now, what's really interesting about this is just how much heavy lifting a reverse proxy actually does. Why do we use it? Well, it handles SSL termination. That means it encrypts and decrypts all that secure HTTPS traffic so your application servers don't have to waste valuable CPU cycles doing it themselves. It also provides a massive layer of security by completely hiding your backend architecture. It offers complex routing, and get this, it even provides caching, meaning it can store frequently requested files right there at the proxy level to send back to the user instantly. Huge performance boost. For those of you who want to see exactly what this looks like under the hood, here is an actual Nginx configuration snippet. It reads location / open bracket proxy _ pass http / backend semicolon close bracket. This elegant little block of code is simply telling Nginx, hey, any traffic you receive, securely pass it along to our backend servers. Being able to visualize this code is incredibly important for what you're going to do next. Which brings us to Section 4, the interactive understanding check. Let's quickly test your knowledge with a direct troubleshooting scenario. Here is a question straight from our source material. A user accesses your website. Why not just directly expose the backend servers to them? Seriously, why go through all the trouble, the configuration, and the overhead of adding these proxy and load balancer layers? Take a second. Think about what we just discussed.
Got your answer? Let's reveal it, because skipping these gateways creates massive architectural flaws. First, it is a huge security risk. You're leaving your delicate back-end servers completely exposed to the public internet. Second, you have absolutely no centralized SSL handling, which makes encryption a total nightmare to manage. And third, you strip away your load balancing capabilities, bringing us right back to that terrifying single point of failure we talked about earlier. Let me give you a real-world tip that will honestly save you hours of debugging. Let's say you're testing an app. The front end loads perfectly, but the back end data is completely unreachable. The application just hangs. What's the issue? Almost every single time, it's a reverse proxy misconfiguration. The front end is asking for data, but the bouncer is confused and won't let the request through to the back end. Definitely keep that in your back pocket.
Let's move to Section 5 and see how this builds into your actual assignment, your mandatory practice tasks. This is your literal gateway to Phase 2.
So the crucial point is, as I mentioned at the very beginning of this explainer, this hands-on work is strictly required for you to pass Phase 1 of CloudBridge Tech Labs. You can't just listen to the theory here. You have to actually build it. You must complete this exact checklist before our next session. Number 1, install Nginx on your local machine or a cloud instance. Number 2, configure a working reverse proxy using the concepts and code snippets we just covered. And number 3, map and deeply understand the traffic flow. Don't just paste code until it magically works. Understand exactly how those packets are moving from the user, through your proxy, to your application, and back.
I'm going to leave you with this final provocative thought to ponder as you start your lab work. Are your gateways truly configured to scale right now? Or are they quietly acting as a single point of failure, just waiting to bring your whole system down? Build resilient systems, my friends. Thank you so much for joining me for this explainer. If you found this session valuable and you want to totally crush Phase 2, make sure to like and subscribe to CloudBridge Tech Labs right now. Go conquer those practice tasks, and I will see you in the next phase.